So in the next script, we are going to check how variables are used in scripts. There are several new things in this script. First, we have an if, else, fi. It's an if loop. So we want to check something. And what we want to check is the variable. So this is the check that we want to do. I will explain it later. And if the check is true, then we do this. And if it's not, then we do this. Now in the check, I am looking if $1 is -z. And to look for that, I'm using the test command. Now the test command, you can write it in two different ways. You can write it test, or you can put the test between square brackets. So what I have here is the same as if test -z $1. Now, if you have a quick look at the man page of test, you can see that you can test many things. For example, you can test an entire expression to see if it is true. Or -z, our test, to see if the string is 0. Or you can compare strings, as we can see here. Or if you go down a little bit, you can compare integers to see if one number is bigger than another number. Or you can do tests on files to check any property of the file. So that is the test command, and the test command really is very useful in scripts. Back to my script. So what it reads here, if test -z $1, which means if $1 is empty, then it is going to enter these two lines of code. So it's echoing enter a name, and it is using read. Now what read is doing, read is taking user input and it is storing it in a variable. The name of the variable that we are defining here is name. So if $1 is empty, then script is going to fill a variable. Now $1 is an argument that can be used while starting the script. So if the script is started without an argument, then the script becomes interactive and it asks to enter a name, and it says read name, and it stores the name in a variable. If the script was started with an argument, then it's very simple, and the script says that name equals $1. So you may wonder, why do we want to store $1 in another variable, and why don't we straight just want to use $1? Well, that is because if we exit the if-else fi loop, we want to make sure that no matter how, we have a variable with the name name, and we can use that variable. And that makes it possible to echo a line where we refer to the value of the variable name. So you have entered the text $name, and that should do it. Now let's run this script a couple of times. So first, without argument, enter a name Laura. You have entered the text Laura. And now we can run it with an argument. You have entered the text Lisa. And you can see no matter how the script is treating the arguments well. Either by using $1 or by asking for a name and by storing that in a variable. And that is a very short introduction on how scripts can use variables to become more flexible. Variables in scripts really are the difference between just the linear execution of a bunch of commands and a smart script that can behave differently under different circumstances. Let's talk about positional parameters. Now, what is a positional parameter? It's just an argument. So anything that is provided when starting the script. If you type ls-l, for example, -l is a positional parameter. It's the first positional parameter. So in a script, you can refer to it as $1, as we have seen in the previous script. And if you type ls-l/etc, we have two different positional parameters, $1 and $2. Now this is something that you can use in scripts as well. This is the way that you don't want to do it. And I will explain shortly why you don't want to do it this way. So this script can test a couple of arguments. So it has 3 lines. The first argument is $1, the second argument is $2, and the third argument is $3. Let's see what is wrong with this script. If we run it, script 3 A, B, C, then it is perfect. Because it treats 3 arguments, and we have 3 arguments. If you run it with some more arguments, it's not as good because you don't do anything with $4, $5 and $6 in the script. And also if you run it with just one argument, the second and the third line are executed anyway. So this is not how you want to treat positional parameters. Let's have a look on how you do want to treat positional parameters. In this script you can see a couple of lines. First you have entered $hash argument. $hash is a counter. It just shows you how many arguments have been provided. It's not very useful, but I want you to be aware of that you can do that. And next it is doing a for loop. A for loop is continuing as long as a certain condition is true. And the condition in this case is for I in $at. So what is $at? $at is the collection of all positional parameters, no matter if it's 2 or 200. And as long as there are positional parameters, the for loop is continuing. So you can read this as for each element in the total collection of positional parameters, do echo $I and then done, which closes the for loop. So let's have a look how this works. Script for 1, 2, 3, 4, 5. As you can see, you have entered 5 arguments. And if you do script for with nothing, you have entered 0 arguments. And if we do it with a whole lot of arguments, then it will do its work anyway. You have entered 22 arguments and it acts upon every single argument. So if you want to write a script that can decently handle positional parameters, this is the way how you want to do it. So in our next script we are doing if then else. We have already seen if then else. Let's just do another example of it, just because it's an important construction in scripting. As you can recognize, we are doing tests again. This test is checking if $1 is a file. This test is checking if $1 is a directory. You can get that from the man page of test. Now the entire if-then construction is the entire script basically. So what is it doing? It is checking if $1 is a file. If that condition is true, then it is executing this line. Elif means that if the condition is not true, it is starting another if test, which is $1 a directory? If that is the case, then it is executing this command. Else, which means in all other situations, which means if it's not a file and it's also not a directory, then it is executing I don't know what $1 is. You notice that there's a backslash in front of $1. That is what we call escaping. We don't want the script to interpret the dollar in $1, we want it just to show a dollar if it doesn't know what it is. So let's run it. Script 5, and let's just put some nonsense. And then you can see I don't know what $1 is. And if we do it on etc hosts, it is a file, and if we do it on etc, it is a directory. And that was another example of if then else. So for is what we use to check something as long as a certain condition is true. Let's just run it before explaining it. Script 6. Did you see that? Now how cool is that? So script 6, what are we doing? We are testing an expression, and the expression is we begin with the initialization of a variable counter and give it the value 100. And we go until the moment that counter is 1. And as long as that condition has not been met, we do counter minus minus, which means that we decrease the value of counter with 1. So after the first iteration it will be 99, 98, 97 and so on. And as long as this is true, we do echo $counter. So this is a countdown script, which is counting down very fast until we have reached the end value, and then it's done. And that is what for is doing. We have also seen it in for I in whatever. That's another method of doing a for loop. For loops are very cool to make sure that an activity is executed as long as a certain condition is true. Now let's do another example with for. for I in 101, 102, and 4. Do ping dash C1 $192.168.4.I done. So what is this doing? Well, this is doing a ping test for I in 101, 102, 4. It is taking the entire series of numbers that I do here. It's just a random series of numbers, and as long as there's a number that it hasn't tested yet, it will continue. Now what exactly is it doing? Well, it is doing ping dash C1, which means that it's pinging one packet only, and it is pinging to 192.168.4.I. So it is pinging 3 nodes in that order, and it is giving me the results. So that is showing me if the nodes are up and running or not. Now you can do that in another way as well. First let me fix something. I don't want to see the output. I just want to see if the node is not available. So I'm redirecting the output to dev null. And I'm putting in a logical test. So the logical test is the double pipe, which is a logical OR, which means if the first part of the equation didn't work, do the second part of the equation, which is echo $I is not available. Let's do this again. It takes some time, but here you can see the result. So what is it doing? Well, it's still pinging these 3 numbers. For each of these ping commands, it redirects the output to dev null. I don't want to see the results because it's way too much information. I just want to know if the node is not available. So that is the logical OR, which means if the previous command returned an exit status other than 0, which means it was unsuccessful, then we are going to execute this command, which is echo $I is not available. And you can see the result here. And this is another way that is very convenient to do a test using for. So in this script we see while. While is something that you can use to check as long as a certain condition is true. Until is doing the opposite. It will be active until a certain condition is true. Now in this script the condition is this, basically. So we execute a command, and we execute the command repeatedly, and the command is ps-aux pipe grep $1, pipe grep dash v grep, pipe grep dash v bash. Grep dash v, as you should know, is what you use to exclude certain results from the command. So the idea is that in ps-aux we want to grep for something, a process. We want to monitor and see if a process is available. And we want to avoid having false matches, so we exclude processes that contain the text grep and processes that contain the text bash. As long as this is true, well, the script is just going to sleep 1. It's sleeping for 1 second. And the next second, it will go through the iteration again and again and again and again. As long as the condition is true, it will do that all the times. Now, if the process disappears, then the condition is true no longer. So it will exit from the loop and it will execute the commands that are here. So it will do a clear and echo your process has stopped and logger $1 is no longer present. I think we can test this by doing a test on HTTP. Do we have HTTP? We have HTTP. Very good. So I need 2 consoles here. And I need to run the script /HTTP. So it is doing its work silently, not silently, but because I used a redirect to dev TTY11, so it's on virtual console 11. But for the rest, it's not annoying me. And if at this point I do a kill all HTTPD, then you can see the script immediately reacting. Your process has stopped. Now, isn't that cool? It's kind of monitoring if a process is still available. Also in the script I'm using logger. $1 is no longer present. Logger will send it to syslog. So normally if you check var log messages, you can see the message occurring right here. Let's have a look at an until example as well, which is in script 8. So what do we see here? Until users pipe grep $1 def null. So the users command is showing us all users that are currently connected. User, user, and user. So until in the users command the value that we are grepping for is present, the script is doing what is in the loop. So echo $1 is not logged in yet. Sleep 5 done. And once the test is true, it will exit the loop and it will execute the commands that are following here. So echo $1 has just logged in. That's the first thing. That's an echo to the console. And another thing that is nice to be aware of that I'm using here, mail-s $1 has just logged in to root. So this is how we can send an email from a script if something needs to be mailed. So mail-s is the subject. So this will be the subject line and we will mail it to the user root. And we need smaller than dot to conclude the mail command. Without the smaller than dot, the mail command will wait until someone presses a dot and enter until it finishes. And that is how you can use until. Now until is pretty rare, but while is a very common construction in scripting. So let's have a look at case. Case is something that you want to use if you expect different answers. So what we see here, case $1 in, and then it's checking start and stop and restart and reload and status. Now does that look familiar? It probably does, because this is the blueprint of a good old service script as it was used in previous versions of Red Hat Enterprise Linux. So what is happening here? Well, it checks the argument the service was started with. Think service HTTPD start. $1 would be start. And if it is start, it is executing this command. And if it is stop, it is executing this command and this command as well. And if it's using restart, it's executing this command. And same for reload and status. And then we have star, which is everything else. So if something else was used, then an argument was used that is not expected. And then the script gives an echo message which explains how it should be used. In the echo message we see $0. $0 is the name of this script. So the user understands, okay, I need to run this script with start, stop, restart or whatever. Now a few things to be aware of. Case is closed with exec. That's case but inversed. Every option that you want to check is closed with a brace, and the command sequence that you want to execute is closed with a double semicolon. And as long as you know how to do that, well, you'll be good using cases. So there's one example that I can do with script 9, and that is blah. As you can see, it is doing the usage here. If I do it with start, well, in the script, as it is an actual example, it is trying to execute start. There is no start command, and that is because within that same script there are functions. I'm not covering functions here, but I just want you to be aware why it doesn't work exactly in the way you want it to be. So here is my solution to the exercise. I made it a little bit fancy because I wanted to take the opportunity to explain some additional stuff as well. First, we need to check if an argument is provided. So if -z $1, then enter the amount of minutes and read counter. So we are filling a variable counter. And if an argument was provided, then counter is filled with the value of the argument. Typically, I expect counter to contain minutes. So if you want to count down seconds, well, we need to do a little calculation. And the calculation, you do that by doing counter equals $, and between double braces, the calculation itself, counter times 60 this time. So the result would be that you get seconds. The next thing that I'm using here is a function. Now, functions are quite common in scripts, and I wanted you to be aware of how you can do functions anyway. So the function name is -1, and to define the function you need name, opening brace, closing brace. And all the commands that you want to assign to the function are between curly braces. So the commands are counter equals $counter -1 sleep 1. So this is what is going to count down. The function in this script is executed just once, which is a little bit lame. You can execute it several times as well. So what we are doing here, we do an integer test, and the integer test is a counter greater than 0. Do echo $counter seconds remaining, and if that's the case, it's doing a -1 and it is done. And if counter equals 0, then we do the logical AND. Of course, you can write this as an if then else as well. If test counter equals 0, then echo time is up, FI, that would work as well. But we have seen the logical OR, which is the double pipe, and I wanted you to see the logical AND as well, which is written like this. And the result, well, if we do script 10, 1 for 1 minute, it is going to count down. So there we go, time's up, and this is how you could have done the scripts. And I know there are many different ways of doing a script like this. The idea is just that you have had the opportunity to play a little with the elements that we have discussed in these lessons about scripting.